And in linear motion, we have acceleration. Then in the rotation, we have angular association. So, so by doing this, so now the next thing is what causes the motion. The motion in the linear motion is called force. We call the evidence of change of motion is the existence of forces. So then we develop another thing, our previous section. In order for rotation to occur, there must have some kind of identity, in which case we call torque. We call tau, and we find out that tau is equivalent to force in the linear motion. The angular, in the rotation, we have tau. Okay, now in motion, we have velocity. In here, in the angular motion, we have omega. And then we have acceleration in linear motion. This is a linear. This is a rotation. Basically, it's almost one-to-one correspondence. And by doing this, then this one have what we call angular association. See, we get each one identical, corresponding to one another. So that makes the learning easier. So if you like to find out the analogies and comparison, you don't need to what they call memorize this, but just knowing one, then you can doing another one. So in these cases, you have some kind of resistance to the motion is called mass. And the resistant motion we call inertia. So there's something equivalent to this in rotation, in which cases we call the mr squared. Or we like to say this is called moment or inertia. Moment of inertia. In which cases it's called I. So I is equivalent to m. And then inertia is equivalent to moment inertia. So everything is made up. So in this case, as far as tau goes, we study this. In their cases, we like to adding another section, in case 10.7 section. That means torque, T-O-R-Q-U-E. So we like to anticipate torque. Torque is equivalent to the force in there. So we like to find out in reality what is going on with what we call the tau. So we go back to the circle again in rotation. Here is a circle. In order for this to rotate, we got to have a force. And in these cases, we have an R. In these cases, we have an R. So we're looking at one particular particle. In which case is have a mass m. We know that in order for this to have a rotation occur, we call the tau. So the tau is equal to what we call equal to R times F. Okay, the moment arm times R. You can consider the cross product later on, but in the meantime, you just consider one particle point. F equal to ma. In that cases, r times m. A is equivalent to linear motion. A is equal to r times alpha, right? Acceleration in linear motion, you r times alpha. So in that cases, this one is r times alpha. So that is equal to mr squared times alpha. So after we do all this in here, then all of a sudden we find out that based on this particular information, then something is very nicely occurred to us. In their cases, that was give to